What I want to do today is do a short video on the Coriolis effect, and this is something that makes anything that's free moving on the surface of the Earth, like wind in the atmosphere, water in the ocean, airplanes, boats, anything that's not in direct contact with the Earth, like a car or a bus or you. But anything that's freely floating on the surface of the Earth will look like it's going to bend due to the rotation of the Earth. And that actually happens because you're leaving sections where the rotation may be faster or slower than where you're headed. But in the northern hemisphere, because we move in a counterclockwise direction, the Earth actually rotates from the west side towards the east, which makes the sun look like it comes out of the east and sets in the west. But we rotate in this direction. Believe it or not, this is a counterclockwise direction. If you can actually go in a counterclockwise direction, imagine if you were looking at it from the other side, it would look like it goes clockwise. So whatever happens in the northern hemisphere doesn't happen in the southern hemisphere. So what we're going to do is we're going to look at a side view of the planet and also a top view of the planet, and we're going to go on a non-rotating Earth. We're going to watch a plane as it travels, hopefully in a straight line. Here we go. And notice that it moves in a straight line. Notice that it moves in a straight line, moves down lines of longitude. Okay, now we're going to do it on a rotating object. There's where it went. There's where the target is. Notice, watch it one more time, the plane actually goes in a straight line. But because the Earth actually moves, the line that it wants to obtain keeps moving off this direction. It looks like it rotates or spins off to the right. Now, why is this to the right when it is to the left? You have to imagine where it was. And here, this is, if I could spin it around the other direction, if you were standing here looking in this direction, it would look like it goes to the right. And it would actually spin in this direction. This one will go from west. This is what it wants to do. Now we're traveling on lines of latitude, but it still gets deflected to the right. And this is called the Coriolis effect. It doesn't really happen. What's going on is that we're moving on a moving object, a rotating object, and it seemingly makes things look like it changes. Real good example of this is if you've ever seen the back of an airplane guide when you're traveling, and you see these great paths of travel. If you actually traveled on the planet, the easiest way to get and I live here in Northern Virginia, easiest way for me to get to England is not to fly around like this. It's to actually go up and catch England when it actually lands, when it rotates over to this direction. So what it does, it makes me look like I move this direction. Okay, that's Coriolis effect in a nutshell. An apparent force caused by the Earth's rotation, a rotating object. Bye.